Beyond examining specific concrete bits of reasoning, such as some students are chemistry majors, no chemistry major is well rested, so some students are not well rested, we can also consider more abstract forms or patterns of reasoning, such as A or B, not A, so B. We say that a form or pattern of reasoning is valid just in case any inference fitting that form would have to be valid. So as an example, consider this form of reasoning, A and B, so A, where A and B are meant to stand for whole statements. An example of an inference that fits this form is Jane is 30 years old and she is a teacher, so Jane is 30 years old. That's obviously valid, and clearly any other inference fitting that same form would be valid too. So the pattern of reasoning A and B, so A, can be regarded as a valid form of reasoning. By contrast, consider the form of reasoning A, so A and B. This is not a valid form of reasoning, since not every inference that fits this form is valid. Some inferences that fit this form are valid. For instance, consider the inference Jane is 30 years old, so Jane is 30 years old and she is over 21. That's valid. The problem with the form of reasoning A, so A and B, the issue that prevents us from regarding it as a valid form of reasoning, is that some of its instances are not valid. For example, Jane is 30 years old, so Jane is 30 years old and she is a teacher. This is obviously not a valid inference, since being a teacher is not a necessary consequence of being 30 years old. Because not all of the inferences that fit this pattern are valid, we don't consider it a valid form of reasoning. Now, just for a little practice, let's look at some other forms of reasoning and assess whether they are valid or not. Starting with this one here, some F are G, no G is H, so some F are not H. Is this a valid form of reasoning? Now, we don't actually have any systematic method on the table yet for figuring out the answer to that question. It would be really nice if we had some step-by-step procedure that was easy to follow and that we knew would give us an answer. We don't have that yet. We'll actually work up to something like that over the course of this semester studying formal logic. For now, we just have to use our ingenuity to try to figure it out in whatever way occurs to us. We do know that whether this form of reasoning is valid depends on whether it's possible to have a situation where these two premises are true, but this conclusion is false. Is this possible to have a situation like this? That's the question that we're facing. So one thing that we could try is, okay, can I envision that? Maybe start by saying, okay, what would it be like if this conclusion here were false? It says some F are not H. Some things that are F fail to be H. If that were false, that would mean everything that's F is H. Okay, so to represent visually, since that might help, what it would mean for this conclusion here to be false, I could draw a circle for all the things that are H, and for this conclusion to be false would mean that all the things that are F are H. So that would mean if I drew a circle for F, it would be inside of this circle of all the things that are H. This would represent a scenario where everything that's F is H. And now that I have depicted a scenario where this conclusion is false, can I make both of these things true? Well, let me start by trying to imagine that this first premise is true. Some f are g. Well, that means that the things that are g have to overlap, at least to some extent, with the things that are f. So g is going to have to be, the circle representing the things that are g is going to be something like this. It's going to have to overlap at least a little bit with the things that are f, but then that means I'm going to have at least some things that are g and h. I mean, it doesn't have to be exactly how it's depicted here. There could be some things that are g that are not h, like these things out here, but because g and f, based on the first premise, are going to have to overlap at least a little bit, there are going to have to be some things that are g and h. And so this second premise here is going to have to be false. I cannot make this false and this true and this true. Once I make this conclusion false and this first premise true, I can't make this true anymore. So this kind of scenario isn't actually possible. And so that tells me that this is a valid form of reasoning. As soon as these two premises are true, this conclusion is going to have to be true as well. Another way to see that would be to start by imagining both of these premises being true and then seeing that that automatically forces this conclusion to be true as well. So to think about it that way, let's suppose I have a big circle representing all the things that are f, and the first premise tells me that some of the things in here are g. So there's got to be at least something in here which has the property g, whatever that is. Okay, so let's pick that thing to be one of the things in that is f that has the property g. And now to make the second premise true, it tells me no g is h. So nothing that's g has the property of being h. So in particular, this thing can't have the property h. So this thing here is not h. But now I automatically have something which is f and not h. So once I made these two premises true, that forced this conclusion to be true as well. So that's another way of seeing that this is indeed valid reasoning. This is a valid form or pattern of reasoning. Okay, moving on to a different example here. This time the pattern of reasoning is some f are g, some h are f, so some g are h. Is this a valid form of reasoning? Well, again, we don't have any truly systematic way to approach this type of question, but let's try seeing if we can create a scenario where this conclusion here is false, but these two premises are true. Can we create a situation like that? To make the conclusion false, some g are h, we need to make the things that are g and the things that are h totally disjoint. They can't, those two properties or categories can't overlap at all. So it would have to be a situation like this, where we've got the things that are g and the things that are h, and there's no overlap between them. Okay, that would make this false. Now, can I still make these things both true? Well, you know what? It occurs to me that one way I could do that is by having the category f, the things that are f, be some huge group that includes all the things that are g and all the things that are h, like this. if that's how things were, then we'd have some things that are F are G. Some things that are H are F. In fact, all the things that are H are also F. But nothing that's G is H. There's no overlap here. So this shows me, it looks like I can create a scenario where these things are true, but this thing is false. And so this is not going to be a valid form of reasoning. Now, if this really is not a valid form of reasoning, I should be able to create a specific instance of it. I should be able to create an inference that fits this pattern that is not valid. And in particular, it'd be nice to create one that fits this pattern, that has premises that are actually true and a conclusion that's actually false, which we know would mean that it's not a valid inference. So let me try to do that. So I want to pick, let me start by creating my conclusion. So I want to create a conclusion that fits this pattern, some G or H, but I want it to be a conclusion that's actually false. So I need to pick a category G and a category H that don't overlap at all, like in this picture. So let's say sharks as the category G and professors as the category H. Some sharks are professors. Well, that's obviously false. I could use that as my conclusion. So sharks are used as the category G and professors are being used as the category H. And now I need to create premises of these forms that are both true. And if I follow the guidance of this picture over here, I can make the category F some really big, huge category that both sharks and professors belong to. And just because sharks and professors both belong to that much bigger category doesn't mean that they overlap at all. So, a good category perhaps would be like living things or living creatures. So I could say that's going to be my category F, living creatures. So I could say as the first premise, some living creatures are sharks. And as my second premise, I could say some professors are living creatures. Now, that's an understatement, of course, because we can say that all professors are living creatures, but that doesn't make it wrong to say that some professors are living creatures. That's still true. So these two premises are in fact true, and this premise is in fact false, of course. So we have here an instance of this form of reasoning that is clearly not valid because the premises are both true and the conclusion is false, and there can't be any valid reasoning like that. So that's another way of showing that this is not a valid form of reasoning because it has instances which are not valid. Okay, here's another form of reasoning. All F are G, some F are H, so some H are G. Is this a valid form of reasoning? Well, this time let's try supposing or imagining both of these premises being true and see if that forces this conclusion to be true. So we start by imagining that everything that's F is G. So if I draw a picture representing all the things that are F, we know everything in there has to be G. So whatever thing I pick in this circle, it would always have to be G. And we know that some F, or we're going to imagine to make the second premise true, that some F are H. So there has to be something in here that is H. So if I just pick something at random to make H, that will make this second premise true. So let's say I pick, this one down here to make H. So I'll write H next to it. Suppose that this one is H. But now I've already made it true that some things that are H are G. So once I imagined these two premises being true, that automatically made this true. So that's a way of seeing that, yeah, this form of reasoning is valid. Okay, finally, here's one last example. No F is G, no H is G, so some F are not H. Is this a valid form of reasoning? Well, let me try the strategy where I try making this conclusion false and these premises true, and see if that's conceivable. Can I envision a scenario like that? To make this conclusion false, some F are not H, some F fail to be H. For that to be false, every F has to be H. So visually, what that looks like is if here are the things that are H, if every F is H, that means F has to be like this. All the things that are F have to be H. So that would be this conclusion being false. And now can I make it the case that no F is G and that no H is G? Well, if I just put G, the things that are G all the way over here, they don't overlap at all with the things that are F, and they don't overlap at all with the things that are H, then I've made these premises true and this conclusion false. So this looks like it's not a valid form of reasoning. One way to further confirm that this isn't a valid form of reasoning is to give a specific concrete inference that has this form that isn't valid. So let's try to do that. Okay, so first let me try to create a conclusion of this form that is in fact false. Some F are not H, so I want to have a conclusion like this that's false. So I want to pick a category F where everything that is F is H. I want to pick a category F and a category H that make this picture true. So let's say, how about some sharks are not living creatures? That's false. Every shark is a living creature. So now I've got a conclusion that fits this form that's false. That's what I wanted. And I want to make premises that fit these forms that are true. And so then I'll have a inference that fits this pattern where the premises are actually true and the conclusion is in fact false, which will show me that that inference cannot be valid. Okay, so let's make premises that fit this first form and then that fit this second form that are in fact true. So sharks are acting as my category F here. So and living creatures are acting as my category H. So I want to pick a category G where no shark belongs to that category, and indeed no living creature at all belongs to that category G. So let's say things that are made of stone. That would work. G can be being made of stone. So then premise 1 would say no shark is made of stone. And premise 2 would say no living creature is made of stone. Now I have an inference that fits this pattern here. And the first premise is true, no shark is made of stone. The second premise is true, no living creature at all is made of stone. So some sharks are not living creatures. That's false to say some sharks are not living creatures. So this inference here cannot be valid because the premises are actually true and the conclusion is actually false. So here we have an inference that fits this pattern where that inference is not valid. And so this is not a valid form or pattern of reasoning. Not every inference that fits this pattern is valid.